to say a few words about ICTP?
Well, welcome. Thanks for joining. We have this new format we're testing now. So today is a bit of an experiment. Thanks for being part of that. And we're using this new, Google Meet so that we can get the YouTube videos as soon as possible so that people that cannot join can still watch the video on YouTube almost immediately. And with that said, I think we can get started. And Jeremy, please, want to introduce the speakers.
Oh, that's a good point. I don't have the speakers list. We've got Juan starting off, and his screen is already up. And then we'll have Nickson after that. And we are still waiting for Shahzaib, but we'll probably go in that order at the moment since Nickson's already here. So, are you ready to get going on?
Yes, I am ready.
Excellent.
Okay, I started?
Yeah.
Yes. Hi everyone. First, I really appreciated the opportunity to take this explanation. I'm going to talk about my first step to the development for the auto recognition with ESP32COM. My name is Juan Mena. I am a student of biomedical engineering at Peruvian University, Cayetano, Heredia, here in Lima, Peru. I'm going to talk about eCuba. eCuba is a project whose purpose is create a garbage collector with the capacity to classify different kinds of trash. Why? Because we want to make a good recycle process, but in my university, not all the people put the trash in the correct collector, and this is a problem because when the person wants to take the garbage and recycle, he look another type of trash. For example, organic trash, when the collector is only for the plastic trash. You can see in this imagine how this person has different type of trash, bananas and other things. These mistakes create a problem when the people want to recycle. And then what is our project? Our project is create this collector with the camera and classify the garbage with the objective to create a conscientization. Sorry for the word. I don't know if it's okay. And make more efficient the process of recycle. And then the principal idea is take a normal collector and convert it to the smart collector. How we are going to do that? We are going to use ESP32COM. You can look this image in my presentation. ESP32COM, depends on the person who created this development board. Use a chip. Usually is the ESP32COM D0 DB6Q. Is around here. And what is this chip is very important. This is important because with this chip we can develop the Internet of Things. In this case, we want to connect a collector to the internet. And this is amazing. We can analyze the trash process. We can look how, for example, we can see how the people take the trash in a specific hour. Maybe the people put the trash in the 7 a.m. I don't know, and we can think about it. The people it is how do you say, no, the dinner is take the breakfast in this hour, and this chip is very well, no, it's in December expensive, but it's very cheaper and have a good quality. Then, and the idea is put the HP32s inside the collector. And how are you going to do that? I'm going to use this 3D model. This model, you can get it in this website. It's for free. It's for the free access. And in my university, we have a 3D printer, and this picture is from the website, but our model in this moment is printed. When with the green part, we can cut a hole with the wall collector and put to the garbage collector floor, and see what trash is enter to the collector. And then, where the phrase is pressed, I'm going to try to detect a bottle. To get it, I'm going to use the eloquent library and a impulse. You can see in the image how in the image to the left, I'm pointing to my table, and in this part you can see in the box. Well, it's very tiny. But say that non-detect nothing. But in this case, when the bottle is in the table, say that yes, the bottle is here. Well, this is the explanation how I did it. This is the library allocating HP32 can. I decided to use this library because this library has a commands too simple. You can use all the libraries for the ESP32, but this library is complex. But the eloquent library, there are commands who you only have to put in the code, and you use it, and it's working. In this case, I'm going to use when I installed the eloquent library, I used this example 26. This example has give me a link to the internet. With these links, I go to this page, and in the page there I am seeing what is the SP32 CAM is analyzing. In this case, in my table, I am looking my bottle, and I start collecting photos. I'm going to use these photos to train the algorithm, which I'm going to put in the chip, and when I turn on the SP32 count, I'm going to analyze and say me is the bottle it's here or not. Well, this is the page of the engine pulse. I'm not really sure that Marcelo made it very well. I put in data addition the data. In this part, I am using 118 items, and you can see how the bottle has a label with the name botella. Botella in bottle in Spanish is botella. And well, the design of the pools, I am using these parameters, and the imaging object detection. And in the imaging, I selected grayscale because when someone use grayscale, the SP32 chip don't have to do doesn't have to do doesn't have to do very a lot of cycles. When the grayscale, the cycle is the cycle is slow. Well, in the object detection, I did the training and download the library, the program in the form to the Arduino library. Well, the library was get like a .hp format with this name, and in this moment I was to install the library. The library was installed, and I was going to the I went to the HP32 camera, and I going to copy this part, this line, the line 24. Why? Because this line is the library, and I didn't use this code because this code, yes, this code is understandable by the people with no linguistics C and C++, but it's a little bit complicated. But with the Eloquent library, we have this example, the example 27, and well, the example is very large, and for the reason I don't put it in the presentation, but it's more simple, and only has to change the library in the line 9, and then run the code. Well, you can so in the imagine how in the imagine to the left, how the model, well, how the SP32 didn't recognize something because there isn't something, and in the imagine to the right, yes, recognize the bottle. I have this video. This video don't have a very good quality, and so I'm apologize by it. But you can show how when I put the bottle in the point of view of the camera, and the speaker to recognize the bottle and send me a message. How it not detect nothing when I put the bottle, recognize the bottle. And when I remove the bottle, the speaker to say me don't detect something. Put the bottle again and send me yes, the bottle is here, and remove and the bottle, and well, put the bottle again and say me yes, the bottle is here. Now, so in this part, the ISP22 send me the bottle is here when the bottle it isn't here, and it could be happen because I only use 118 photos. This will happen because when the number of photos it is enough numbers of photos, the algorithm maybe not need more information, but when something is when I hold this, well, it's very important has to more information to the algorithm, because when the camera looks something part who it wasn't trained, maybe have some mistakes. Now, how are going to be the next steps? The next step is look the video and so in what parts what is the SP32 camera is showing. in my old presentation, you only saw the SP22 send me a message, but I want to show what is happening. I want to show what is happening inside the garbage collector. Well, thank you very much. I want to appreciate your time and your attention too, and I want to say thanks to my university, the UPH Biomedical Engineering Laboratory. Yeah. Thank you. If you have any comments or questions, I'm going to be very happy to hear.
Thank you there, Juan. Great presentation and good watching you going through the training process. Does anyone have any specific questions for Juan?
Yes, Jeremy, can I ask a question?
Yep.
Juan Manuel, thank you for your presentation first. And I want to ask you if you thought about the problem of the light of the photos, because you need photos inside the trash container, right? So maybe how if you think how will it work with the photos with very low light and with noise also, with other objects? I don't know if you try something.
Yes, you're right. The idea is start to take photos to the floor of the garbage collector. Yeah, and yes, a little bit problem are going to be the light. But we have two ideas with my teacher. The SP22 can have a LED. Maybe I was thinking use these LEDs to how do you say, illuminate, to light the garbage. And another idea is the SP22 camera has ports pins with a general purpose. Another idea is put a LED or more LED, I don't know, 5, 6 maybe. Not necessarily in the board, maybe around the collector, with the pin give the voltage to light the garbage and take a very good photo.
Okay.
Are there any other questions for Juan? I think as the garbage container fills up, it's going to be very interesting and complex how your project's going to work with it. I look forward to hearing how it works out. Anyone else before we move on to Nickson? And I see that Shahzaib is online. So Shahzaib, if you can present after Nickson, I think that would work really well. Thank you so much, Juan, for your presentation. And Nickson, can you try to set up the presenter in the Present Now box? And just double checking. Nickson, do you want a mic on? While we're waiting here. Hi, VJ.
Can you guys hear me?
We can. Can you take over screen?
Can you see my screen?
Not yet.
Oh, okay, wait.
Now we can. Perfect.
Okay.
Go ahead. This is Nickson.
Yeah.
If you can introduce yourself.
So, hello, can you guys see me?
Yes.
So, my name is Nickson Kiprotich from Dedan Kimathi, University of Technology, Kenya. I'm taking mechatronics engineering. So I'll be presenting to you Kai. Yeah, so I'm here with my partner, Ryan Kiprotich. Maybe you can say hi. Hello, Ryan. Are you here? So I'll begin.
Hello,
So
my name is Ryan. I'm his teammate. Maybe you can continue with the presentation.
so Kai is an AI-powered device that aims to reduce the number of deaths and accidents caused by seizures. So it's an wearable device that's able to detect oncoming and ongoing seizures in real time and alert caretakers. So from the data we can see here, it's from the World Health Organization. It shows that more than 50 people in the world have epilepsy. So we are considering the population of epilepsy because most people with epilepsy suffer from seizures. But there's also a higher population of people with chronic illnesses that also have seizures. So I'll go to the next screen. So this shows the kind of accidents that people with seizures suffer from. You can see the leading one being head injury, because we know that when someone has a seizure, there is normally unconsciousness. So there might be falls that might lead to head injury, accidents, burns, also there's dental injury, fracture. Yeah. So we decided to come up with an idea that's able to detect these seizures before they happen or during their happening and alert caretakers in real time. So we tried several solutions and we were trying to come up with a solution that's able to detect seizures and alert caretakers, that's able to reduce the number of deaths caused by seizures, and also a solution that is affordable and reliable. So the solution that we could find, we decided to use TinyML, because in TinyML, you can run the AI model on the device. So the parameters that we are using to detect the seizures is the body movements, heart rate, temperature, oxygen concentration, and brain signals. So for the body movements, we know that when somebody is suffering from a seizure, there's normally shaking and muscle stiffness. So from that is where now the model can recognize the specific type of movements that's associated with seizures and alert. So same goes for the heart rate, temperature, oxygen concentration, and brain signals. So in our project, we decided to use Arduino Nano 33 BLE Sense, ESP8266, the EEG sensor, and the MAX 3102 for heart rate and oxygen concentration. So we are using Edge Impulse to train our model. But currently we are having a problem with sensor fusion. So the model we have only uses the built-in accelerometer from the Arduino Nano 33 BLE Sense, but we are also planning to integrate the other sensors. Yeah, so the ESP8266 here is for the communication, like the IoT application, to send the notification. Yeah. So the main reason why we decided to use the Nano 33 BLE Sense is because of the several onboard sensors. Now from the sensors, like the temperature sensor, we are able to detect the body temperature of the patient, and also we can detect the humidity of the surrounding. We also know that the Nano 33 BLE Sense has the light sensor. So when you normally watch some YouTube videos, you normally see that you are being alerted that if you're epileptic, you shouldn't watch the video. So we will be using the light sensor to detect the flashing lights, because flashing lights can trigger seizures. Yeah. So when there are flashing lights, the device can alert you that you're in a threat of having a seizure. So you should be away from it. Yeah. So the other reason we're using the Nano 33 BLE is because you can deploy a machine learning model on it, and also for its Bluetooth ability. Yeah. So here is a breakdown of how the device communicates. So when the device is triggered, for example, when the seizure-like symptoms, the device first vibrates and releases a sound that the people around the patient can hear, and they can know that he's experiencing a seizure. So another problem we are having is that not everybody has internet connectivity. So we are using the Bluetooth option of the Arduino Nano 33 BLE. So it will connect with the phone, then send the notification to the phone. The phone now will act as a gateway with the cloud. Yeah, so from the phone is when the data can be sent to the IoT hub. We are using the Azure cloud. Yeah, so since you're also using the ESP8266, the data can be sent directly to the IoT hub. So from the IoT hub, the data we already have the model on the device that detect the seizure, but we also have another model on the cloud that's able to detect the data and identify whether it's a seizure-like symptom or it's a normal person body symptom. So from there is where now, when there's a seizure-like symptom, an email notification is sent to the caretaker or the family members of the patient. So here is a demo of how the device worked. So in this demonstration, we were only using the accelerometer. That's why you are seeing me shaking my hand. So we know that when a person is experiencing a seizure, there is normally the shaking movement of the hand or the stiffening of the muscles. So we trained our model to be able to identify these movements and the normal hand movements. So it cannot confuse the normal hand movements from the movements that indicate a seizure. So as you can see, when the shaking is detected, a red LED will blink and the notification will now be sent to the cloud. Not to the email of maybe the caretaker, the patient, or the family members. So this one here is the web dashboard of the maybe the caretaker or the doctor attending to the patient. So you can see the data of the patient, either the temperature, oxygen concentration, heart rate, and body movements. So the graph here so shows the progress. So the patient is able to know whether the seizures have been frequent or not, so the doctor can advise them accordingly or on what they should do. So the main challenges you are facing currently is the data acquisition. You know, the health data is very sensitive and you normally don't find it anywhere. That's why now we are having the problem to get the data to train our model for the seizures. Yeah, but we are trying to partner with some patients and also some hospitals where we can get the data to train our model. Also, there is hardware optimization. You know, the Arduino Nano 33 BLE sense has some limitations. Its processor is not that much as fast as the one we require for our project. Yeah, we also need funding and for the regulatory. You know, for you to get a product out there working, you need to get the certification from the health organizations. Yeah, and we also need to partner with some organizations to help us develop the project. So our main target market is the epileptic patients and patients with chronic illnesses. And also, since it's a wearable device, it can be used to track fitness. Yeah. This is the team that I'm currently working with. Ryan is the only one here, but
Nickson, did your sound go off for a minute? I haven't got contact with Nickson at the moment, but great project. Really, really complex and quite the big picture plan. Does anyone have a question for Nickson or Ryan? And Ryan, is your mic on?
Hello.
Yeah, good. Does anyone have a question for them?
Juan has a question. Yes.
Hello, thanks. First, I like your presentation, Nickson. I was very interesting, but there are something that for me it isn't clear. When in the imagine you use you put the imagine who your brain maybe with the devices, and I don't know how the devices recognize when is epilepsy and when is another movement.
Let me first be clear. Are you asking how the device detects the seizures?
No, not the movement. Detect your parameters.
Oh, the parameters.
Yeah, and what's parameter used to recognize epilepsy? How the
okay.
Yes. Yes. Sorry. Continue.
So to answer your question, so what's happening, as Nick had told us, we have the model taking that from an IMU unit, initial measurement unit. Initial measurement unit, what it's doing, it's looking for the convulsive motion that happens during seizures, and then it's also taking heart rate data and oxygen concentration. So all these, when we have all of them going into the model, as soon as the requirements are met for a seizure, is when now the model marks it as a seizure.
Okay.
It's the sensors that are working together, not an individual sensor detecting seizures.
Okay, and why is necessarily the accelerometer?
So the accelerometer, we have the accelerometer and the gyroscope. So what we are doing, let me demonstrate with my hand. Can you see my hand?
Yep.
So in case of a seizure, you'll find somebody having motions like this. Okay, I think it's called convulsive motion. So what's happening if I have an accelerometer here? It's able now to give us the data of this motion going on during the seizure. That's why it's useful to the detection.
Okay, amazing. Thank you.
Okay.
Yeah, Nickson and Ryan, the sensor fusion part of combining all that, that's really quite a complex part of your project. What's the next sensor you're going to try to activate?
So we had the main sensors that we have been successful in using has been the IMU, the accelerometer and gyroscope. Then we have the Max 31 102. It's an oximeter and heart rate sensor. And now this one gives us we have so far it's 4 parameters. Now the problem we had when we tried to extend these parameters was we had the model crashing. So we've been looking into maybe things like RTOS, so that it can help us with the CPU time partitioning in our model. So if we're successful with that, we believe that it will be adding more and more sensors, including the ECG sensor finally to the model.
Right. Yeah, that's a hard project and problem. Good luck. Good luck for both of you on that. Thank you so much for the presentation. We do
only a comment, Jeremy, before Ryan and Nickson. One thing that's very important when you are trying to do this, the sensor fusion, is to work with the pre-preparation of the data. Okay, I mean, because you have different sensors, the good thing is took the data, do a kind of a pre-preparation, transform the data in something more simple that you can feed for your model and define what kind of a model you guys will have. And of course, take in consideration that everything that you do in the training will be, of course, it needs to be implemented in the final hardware, let's say. Okay.
Okay, thank you for that.
Thank you.
Is there any more question?
Yeah, any quick questions? Doesn't look like it right now. So Ryan and Nickson, that's a great project. Good luck. You're gonna have to update us in 6 months or whenever when you've got some more sensors going. And
Okay, we'll surely do that.
The training must be very difficult. Good luck with the project. We have Shahzaib. Nickson, can you take off presentation mode?
Okay.
And there we go. Shahzaib, can you try to do presentation mode and introduce yourself?
Hi everyone, myself Shahzaib Ali. I am from National University of Science and Technology from Pakistan, and I did mechatronics engineering from there, in Bachelor's of Mechatronics Engineering. Let me share my screen. I hope the slides are visible to you.
Yes.
If there is any noise behind my background, should I continue? Hello.
Yeah, please
Yes.
go ahead. Yeah, that's fine.
So actually in my final year project, I have done a project in which I classified the fetal heartbeats as regular or irregular. That basically is a handheld device that will be used for domestic purposes, not for the purposes of for doctors. It for the domestic purposes, so that the mothers or parents can realize if their childs have any problem or not, so that they can consult with their doctors. So I have made a model classification model that classifies these regular or irregular signals of heart of the fetal, and I deployed it on this microcontroller, RP2040 microcontroller. uh, for that model deployment development, I used Edge Impulse. I found it very fascinating to use, as it gives me a lot of things to manage the memory constraints. So first of all, I did assume the hypothetical data that from the PhysioNet ATM website, which gave me the data of fetal heart rate monitoring as normal and abnormal signals. So I use that data and then set it up in the Edge Impulse environment, and then trained my model on that by using different feature extraction already provided in the Edge Impulse dashboard, and then use the model optimization technique on there. And then the deployment of microcontroller, that was I think for me what that was a that was difficult part, as it was exceeding the microcontroller memory, and so we have to constrain that. So the functionality deployed on the microcontroller was the calculating the beats per minute of the fetal, and classification of the fetal heart rate signal as a irregular or regular. So by using this formula, I calculate the beats per minute. That is the peak to peak interval, meaning that once the heart beats and then the second beats comes, the interval between that is divided by the time and then multiply it with the 60,000, because that peak to peak interval is in microseconds. In milliseconds. So we can convert into minutes. That will give us a beats per minute. Here's a flow chart for that. Uh, Now, for basically the peak to peak interval, which usually comes around 350 millisecond to 550 millisecond for normal heartbeats. So for that, 110 to 170 beats per minute was categorized for the fetal. Now, in order to check the normal or abnormal fetal heart signal using a machine learning model of classification, so for that, on the embedded device, for RP2040 was an ideal for that. The ML model gives probability score, and on the basis of that score, I have categorized as the fetal signal as irregular or regular. In order to train the model, I use the edge impulse as said. Here is the basic definitions of embedded machine learning. What is? I hope you already know. You are expert in these type of things. And then the TinyML edge impulse introduction is here. And there is a basic flow of the working and then edge impulse. I acquired the data I acquired the data from a PhysioNet. I are also making a separate circuit for that, so that that can be integrated with my microcontroller, so that that can get the data from any hospital. I have requested from my hospital to get a normal data of the fetal heartbeats and the abnormal when they detect that. And then for now the case is that I have already have the data from the PhysioNet. Then I separated the data in training and testing sets, and then the process the blocks for features extraction, like flattening the data and spectral features of the data, and apply the learning blocks such as classifier and the optimization of the training model in edge optimized neural, and then deployed the C++ library on that RP2040 microcontroller. Here is some of the data that looks like this. And it is a time series data that it gives voltage values of the when placed the sensor on the worm of the uh, on the mother worm. This voltage values comes around for. Actually, I observed that the magnitude of abnormal fetal heartbeats was greater than the magnitude of the normal fetal heartbeats. And this is how I separated the data into 80%, 20% testing and training sets. Here is the samples of raw data of the fetus heart signal. Now the classifying that supervised machine learning method, where the model tries to predict the correct label of given data as input. So the data set is labeled as normal and as abnormal, as you have seen. Here the window impulse design, see as I am getting the flattening features and the spectral features, and then feeding into the classification and neural network classifier, and then getting my output feature as normal abnormal fetal signal. Uh, these are some of the flattened features, which include average, minimum, maximum, root, mean square. Uh, these were some values which were coming for after getting from the processing block, that these are some of the values. The neural network classifier will take some input, output, and probability score that indicates how likely this input data belongs to the particular class. I trained the model in different training rates, and that on that training rates I got some learning rates. So I that these accuracy score in the edge impulse windows. So these are some the after getting turning on the EON compiler, and then getting the C++ library to be deployed on my microcontroller. So this was the basic directory structure of the Edge Impulse C++ library, and then for that I built and deployed that on my microcontroller and got these result. That were basically the hard coded result in the like I gave the input raw signal from the data, and then got some of the probability scores. Like for first case, I gave the normal fetal signal data, and then second case for gave the abnormal data, and that shows on the screen as you need to consult a doctor if there is irregularity, and if there is no irregularity, then no need to consult a doctor. Everything is fine. These are some of the results and evaluations. Getting almost getting the same accuracy, but I am trying to get my own circuit so that data should be used for the model development, and then that will be more valuable actually for our device to use. And these are some references, and I actually tell you about how my code was working in here. These are the spectral. These are the features of the raw signal, which I stored in an array, and then I use them, and we can tell if there is any use of uh, classify them as normal or abnormal. So this was the whole project and the concept. I am still working on it to make a proper device for our circuit, and that was all from my side. If you have any questions, you can ask.
Thank you. That looked very complex. I know with my own heart rate sensor, sometimes the data seems accurate some days and not as accurate other days. Did you find similar things with your heart rate sensor? Did you feel like it got really good data each time?
Basically, I am currently working with my professor who is working on a piezoelectric material of 3 megahertz generating frequency that generates. That sensor is something like behaving too much differently. Sometimes it behaves so accurately, and sometimes it behaves like no, I can't see that response. But we are optimizing that sensor for that application. So that sooner or later that PZT material, that actually is a PZT4 material for the piezoelectric. I haven't included that much of that in my slides, but if that idea works, then we will continue with that. So basically that disk PZT4 disk uses the ultrasonic imaging of the vibrates on that PZT. If you have any idea of the piezoelectric materials, that it vibrates when given some certain sound signal or some vibrations on it vibrates, and that vibration is basically converted in the read by an ADC of the microcontrollers, and that we use. So sensor behaves very irregularly, but we have to design some filters for that so that um, we can get our required data.
I think Marcelo has a question.
A very good presentation. I think the project is very interesting. I had a doubt. When the data that you are using is related with, let's say, the information about how the number of the bits, the bits per minute, per second. I don't know the hertz. It's not it's not the shape, correct?
So
or you are doing all the shape of the hertz bit. You know my point?
Basically, it is about the magnitude of that peak generated by the sensor, and that magnitude, we use that magnitude as getting different features of that, like flattening the data as taking averages and standard deviations and root mean square. So these features are really important to get into the processing for classification as regular or irregular.
Okay. I also realized that, for example, in the pre-preparation for your data, you get 2 blocks in the Edge Impulse Studio. You got the FFT stuff, and another one that I couldn't read. So you mixed 2 blocks, correct? What are those? Because it was not possible to see in your presentation. When you define the impulse, you got 2 blocks. No?
Yes, I really wanted to add the visualization, but actually I did this project around 3 months ago. I did wanted to add the visualization of these. It basically shows that I categorize the data separately as normal or abnormal, getting the data from something, and I know at initially I know that it is a normal signal, and doctor categorizes it as a normal or abnormal using the ECG machines, which are highly highly precise, that they categorize as normal or abnormal. So that thing is used here, that we actually know the label. So that is why I categorize as the different things at normal and abnormal column, at 2 different columns. I think I got your point.
Okay. Thank you.
We have just a small amount of time left. Any quick questions for Shahzaib? And Shahzaib, can you turn off your presentation somehow?
Okay, sir. Thank you.
Thank you so much. As we finish up here, any general questions for any of the presenters? I think they were all very, very complex presentations this month, and it looks like everybody's kind of in the middle. They've got something working, and they still have things to work on. So it would be really good to hear back from all 3 presenters as the models get improved. Anything, Marco?
I only, before, excuse me a little, Juan Manuel, I hope that you will participate in my lecture this afternoon in your university, because we'll talk about image classification and object detection, and I think that we can use your example and talk a little bit more. Okay, correct?
Yeah, that's right.
Yeah, Jeremy, as you say, really good presentation on complex issues. So I think in the different show and tells, we have seen different stages of complexity, and I think as these projects have to do with health issues, they're particularly complex and delicate. So very, very good work. And I think we can announce the next show and tell, right, Jeremy, which should be on the 28th, I believe.
Yeah. September 20th.
September. Excellent.
Yeah. And I think we already have 2 presenters, if Adele and hopefully Andreas, but we still are up for more people to get started with some presentations. Any final words there, Marcelo, Marco?
No, thanks very much. I think great presentations. I think I really appreciate that.
Yeah.
Have a good day.
See you next time.
Thank you so much.
Bye,
guys.
everyone.
Bye. 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 All.